All right, let's take a look at Unit 6, Lesson 15, Features of Trigonometric Graphs, Part 1. So 15.1, we're looking at a picture of sound waves for two different musical notes. So what do you notice? Some things that I notice are that curve B, which is the blue line, has a smaller amplitude. It also has a shorter period. Well, no, not a shorter period, a longer period, because curve A has multiple cycles in the time that it takes curve B to have one cycle. They both have the x-axis as a midline. What might we wonder? The first thing I would think of would be, what do they sound like? How do they sound different? How do they sound the same? Is one of them louder than the other? I don't know. All right, so let's take a look at 15.2, and we're going to match the equations with the graphs. All right, and then it says that more than one equation can match the same graph. So we have 6 equations and 4 graphs. So I'll move it so that we can see all of it. All right, so the first one is y equals negative cosine of theta. So notice that there is no horizontal or vertical translation here. The only thing that's happening is a reflection over the x-axis, right? A reflection over the x-axis. And so remember that cosine normally starts at +1, so it's going to start at -1. So D matches that equation. All right, let's take a look at number 2. We have y equals 2 sine theta minus 3. Well, we know that 2 gives us the amplitude. So our amplitude is 2. The -3 is a vertical shift down 3 units. Right, so the midline is going to be at -3. Since it was normally at 0. And so we're looking for the midline to be at -3. It's a sine curve, so it still looks like sine. It's not been flipped or anything. And then our amplitude is 2, so our distance. So it looks like A, because here's your midline, and that's at -3. And then the distance from the maximum to that midline is 2. So number 2 is A. All right, cosine of theta plus pi over 2, that is a shift left of pi over 2. So that means that all of our values have been shifted left pi over 2. And so if we look at this one has, B has, well, okay. So we already know that A has gone down. This one went down. We can see that B has also shifted down, right? So let's see. With this one, our amplitude is still 1. Our midline is at 0, right? So it's either going to be C or D. And if we look at D, normally cosine starts here. Well, that would be a shift of pi to the right. That's one thing that it could be. So it wouldn't be pi over 2 to the left. And so C is going to be our answer. And we can see that because if you were to continue this, I'm not doing a very good job of continuing that. If we were to continue this, it would go like that. And that starting point would be at pi over 2. So that's pi over 2 to the left. So we know that 3 is at C. All right, and then, let's see. Okay, so y equals, number 4, y equals 3 sine of theta minus 2. So again, our amplitude here is 3. We've gone down 2 units. So our midline is at -2. And we can see on B, our midline is at -2. And that amplitude is 3 units from the maximum to the midline. So that one is B. Number 5, we've got sine of theta minus pi over 2. So that is a shift to the right, pi over 2 units. And normally sine starts at the origin, and you can see here there's a shift pi over 2 units to the right. So this one is also D. So you can see y equals negative cosine of theta and y equals sine of theta minus pi over 2 give us the same graph. And then number 6, y equals sine of theta plus pi. That is a shift to the left, pi units. So normally, when the graph is at pi, you're crossing the x-axis. And so if we had continued that one down, that would be at pi. So that is a shift of left pi units. So that one is also C. So again, here we have y equals cosine of theta plus pi over 2. And y equals sine of theta plus pi. And those give you the same graph. All right. 15 point... Well, let's take a look at that. Are you ready for more? We know that our midline is at 15, right? And so we could say y equals 15 plus, and our amplitude is 10. So 10 sine of theta, and then it has shifted. Normally it starts right here. It's shifted over pi, over to the right pi over 4. So we're going to subtract pi over 4. So that's one way of writing it. And then if we want to do cosine, we could say y equals 15 plus 10 cosine, not sine, of theta. And this time it has been shifted 3 pi over 4, so minus 3 pi over 4, because it has shifted to the right that many units. So that's just a couple ways you could write that equation. There's actually a lot more, but that's okay. All right, 15.3, double the sine. All right, so we're completing the table of values for each of these expressions. So we're looking at what happens when we double the angle measure. Okay, so what we're going to do is we're going to take a look at, we're going to use our calculator, and I am going to, we'll use a regular scientific calculator. We don't need a graph because we're going to be drawing the graph. So we're going to clear all that. And then, okay, let me move that out of the way. All right, so sine of 2 times 0 is still the same thing as sine of 0. Then sine of 2 times pi over 12, so pi divided by 12, and that gives us 0.5. And then when we make that pi over 6, we get 0.87. When that's pi over 4, we get 1. Pi over 2, we get 0. All right, then we have, oops, 3 pi over 4. That's negative 1. Let's see, just pi is 0. 5 pi over 4 gives us 1. 3 pi over 2 gives us 0. 7 pi over 4 gives us negative 1. And then 2 pi gives us 0. All right, so plot the values and sketch a graph. All right, so we're going to sketch our graph. So we have the point 0, 0. Pi over 12 is that first marker, and that's at 1/2. Pi over 6 is the next one, and that's up here at 0.87. And then pi over 4 is 1. Pi over 2 is 0. 3 pi over 4 is negative 1. Pi is 0. 5 pi over 4 is 1. 3 pi over 2, whoops, is 0. 7 pi over 4 is negative 1. And 2 pi is 0. So it's going to look something like this. Not always great at drawing these curves, but we do our best. Okay. And then the normal sine curve, remember, would start here, and it reaches its maximum at pi over 2, and then comes back here, reaches the minimum at 3 pi over 2, and then comes here. So it looks more like this. So there's your regular sine curve. So how do they compare? So this graph of 2 pi is kind of skinnier. It has more periods within that same time. So it actually goes through 2 full cycles, where the normal sine curve would only go through 1. So the period, instead of being 2 pi, it's just pi, because 1 full cycle ends at pi. So that's 1 full cycle, whereas normally it goes to 2 pi. It still has the same maximum and minimum at 1 and negative 1, and the midline is still 0. Okay, so what would the graph of y equals cosine of 4 theta look like? So if this period was cut in half, the period of cosine of 4 theta is probably going to be cut in a quarter. So I think the period is going to be pi over 2. That's just a thought. But it's still going to have the same amplitude. The amplitude will be 1. The max will be 1. The minimum will be negative 1. And the midline will be at 0. Right? That's what I'm thinking. And again, we know that up here for number 2, we knew that the amplitude was 1. The maximum was 1. The minimum was negative 1. And the midline was y equals 0. All right, so I'm guessing that's what it's going to be. So I think that since the period is going to be pi over 2, remember that we normally start at 1. And so we're going to end at pi over 2, so it'll start where it ends. Halfway in between those two is the minimum, so that'll be pi over 4. So that means it'll cut across halfway in between and halfway in between. So it'll look something like this, is what I'm thinking. And then if we want to continue, it'll end here at pi again. So halfway in between and halfway in between. And then keep doing the same thing. Again, I'm not great at this. But you'll notice a pattern that was way not curved. That looks horrible, that's okay. So just do your best, and I'm gonna try to fix that part too. But you'll notice that your minimum is always halfway in between your maximum. Your maximums are always halfway in between your two minimums. The midline is always halfway in between a maximum and a minimum. So that kind of makes it easier to graph because they're evenly spaced out. Don't know how I did that. So that's what I think the graph is going to look like. And let's just take a look at the graphing calculator just to see, are we right? So let's get rid of these. And so we had cosine, y equals cosine of 4 theta. And let's see, we went from 0 to 2 pi. And so from 0 to 2 pi is right about there. And you can see we have 1, 2, 3, 4 peaks with a couple of halves. So that looks pretty good. All right. So there's your lesson summary if you want to take a look at that.